Hello, hello. Hey guys, can you hear me? Hello.
Hey, Yeah, we can hear you.
Okay, good. Good to know. So just checking, I think my camera is misbehaving today, which is just unfortunate. I have alternative camera, but I don't think that is the right direction. But I'll just try. I'll give it a shot. Okay, let's see if that works. You can probably see me right here, but this is not how I mount my computer. So I typically mount it like this. So that's going to be like a crazy view. And I don't think you want to see this view. So this is the built-in camera. I have to actually put the screen in a fashion that I cannot really write on the screen. So I'm going to not use the camera for today, I guess. That's the workaround. Or I'll just forget the camera. I don't think you want to see my face. Unless we want to see the face, we'll switch the camera and adjust something and do something like this. But for right now, I'm just not bothering about the camera as such. And let us proceed. Let's see who's here already. And so you see my camera this way. That way it will be possible, but then I cannot write on the screen itself, which is very difficult. So I'm switching off my camera and putting the laptop to rest on a flat surface so I can write on it. Let's see. We have Brian, Kevin, Chris, Sandeep, and other people are still expected, but we'll proceed. If you remember the last time, we were doing a bunch of things into a particular exercise, which is located, I think, in this location. So let's go there. So this exercise, I'm waiting for it to load. And that's the exercise we were playing with this particular repository. And we were connected to a machine in the virtual machine that we have. And inside, we were playing with it. So that's the VM. And it has that particular Git repository, which is where you can also access. And a link to it is already in your notes in OneNote. So you have a link to this Docker files folder, which is what we were playing with the other day. And we will continue further investigations in terms of understanding how do you build something using Docker, somewhat of a complex architecture using Docker as a toolkit. That's what we will be doing, continuing our exercise in this machine. And in there, we have done a 3 container WordPress deployment. If you recall, if you remember that, we had a scenario in which, let's see if I can adjust this. Okay, this one, I want to go full screen like that. And if you remember, we were doing this 3-tier WordPress example, which included a data container, a database container, and a WordPress container. So 3 containers connected together in a fashion that looked something like, you have an end user. Let me grab my pen. And so you have an end user here, and that end user is mostly interested in, visiting some service that you expose. So they will hit some WordPress container to begin with. This WordPress container in turn will connect with the database container, and then database container will store its data in a different container called data. That's the container structure. This was a very simple one that we built ourselves. This one we use an existing image called MySQL image. This one we use an existing image called WordPress image. So that was the setup that we had in this example. That looks like, in the setup that you're looking at. Here is the WordPress container that matches this. Here is the database container that matches this. And then the building of data container was a very, very simple step. You probably remember that we had done that piece already in a early step in that exercise.
So how is data stored in the data container?
Okay, so the data container was built using this Docker file, and it is stored in that folder. That is one way to store this data. So there are a variety of ways to store data. Like in our example, this is not a standard approach, not a standard approach. In a classic cloud setup, what we are doing is basically playing inside a VM. So I just wanted to have a place to store data. That's the reason why I built a separate container to illustrate the point. However, give me a second, one more second. Yeah, adjusting my microphone. So the reason I have this data container is to illustrate a point that you can use it this way, but this is not how standardized setups operate in the context of cloud. What typically people do in, say, for example, Amazon Cloud, is they will use what is known as elastic block storage. So if you go to the storage section here, you will find that Amazon provides you block storage, EBS. Where did it go? I think I zoomed it. So yeah, in the storage section, they give you, oh, why is it disappearing? Okay, storage section, they give you this thing called elastic block storage. And so that block storage is basically a disk. It's a separate disk that is protected by Amazon and all that good stuff. But this gets mounted on a machine. And you can use this disk to store your data separately. And that separate disk, which is EBS, can be backed up into S3, Amazon S3, for example. So that's the classic dominant mode of using a place to store data in the context of a real cloud like this. That's one example. You see other examples.
In the case of this example, the data container, is it a MySQL database?
It doesn't matter.
Okay.
What it does is it's just a place to store stuff. Like it's a folder.
All right.
Like that's it. So you can put whatever XYZ inside that folder, but that happens to be also the location where MySQL stores data, and I'm using MySQL here, and so that's why I deliberately chose that name. But from a practical standpoint, this is just a disk location.
I think I'm just trying to confirm that the intent here is to have a separate container for the database application, so to speak. But
the database application is here.
Right. But then where the database itself is stored is in the data container. Is that what's happening here?
Yes, correct.
Okay.
Correct. Let me clarify for everybody else. The idea here is that we have three containers. This runs the application. This runs the MySQL software called database software or database server. And this third container is like call it a placeholder. It's just a dumping place, my dumping ground. I need a place to dump something here. This data in this database server is stored in that location. So what I do is I mount it here in the dumping ground, so I can keep it separate, safe. Even if these guys come and go away, they go away, they come back again. My data is in a separate location, and that is a simple way to just keep it outside. This thing, I want to keep it in a dumping ground separate. In cloud implementations, what you will do is you will have a WordPress container running, a MySQL container running, MySQL image. So this is your server, this is your application, DB server. And then you want to store your data for this databases. There is some data here, right? You want to store it somewhere. Where do you want to store? You store it in a disk, separate disk that is unconnected with anything else. And its only purpose is to store the database data. So whatever this file structure is inside the database server should be mapped over to this box, this disk. It's not a box, just a disk. It's elastic block storage. or in other clouds, they have different names for it, like Google Cloud storage. Let's go to Google Cloud and find out. So I'm just going there right now, and we'll find out its exact name. So I'm connecting to it, Cloud Console, going there, and then go to console, and you will find there is an exact similar thing called EBS. Like EBS, like Google has another thing, they call it something else. Probably they call it volume. I don't remember, but everybody has their own names. Azure also has a similar thing. So in the storage section, you can find the name. They have, come on. It doesn't like, it doesn't seem to like Edge browser. Google doesn't like Edge browser, it seems. But the best way to find is to go to a compute engine and try to start a machine. So for example, we'll say, I would like to start, I think it is, let me make it bigger. Come on, bigger. No, it doesn't want to go big like that for strange reasons. So I'll go expand it. And here we should be able to go click the compute engine and attempt to start a VM instance. And that will, they call it disk. Oh, what a name. They call it disk right there. And so this is the thing that they call, it is just disk. And so it gives you persistent disk, can be standard HDD or a solid state disk, or you can also attach an ephemeral local SSD if you like. But this ephemeral is basically short-lived. It dies away, goes away. You don't want it to be ephemeral. You want it to be persistent. So you actually get a disk and SSD basically, and you map that SSD, you create a disk. You can create a disk independently. That's the beauty here. You can actually have a disk independently created, managed, and stored, and distinctly different from the VM disk that you get. You can create a VM, and in that VM, you will have a disk that is directly connected. Like for example, there is this boot disk, and you can have more disks connected. Like here, you can say, give me a disk, and you can, add additional disks, and you can select the disk you already have, or if not, you can create a disk. So that's the idea behind separating the creating a persistent disk. You can get a SSD persistent disk like that, and keep that disk separate from your setup, so that anything that is stored in that disk doesn't go away when the machine dies. That's the idea behind this kind of a design, where you basically try to prevent deletion of data. And so I have been using this example in which in my setup, I use a data container, but that's just one way. There are many ways. The best way to use actually is the disk that the cloud provides, and use it to store the database data, use it to store this application data, like I have done in this example. You will see that in the WordPress example. You will see in this example, come on, you will see that I attempt to store my data for the WordPress image, this WordPress service. I store my data outside the container in a folder called home user Docker files WP content. That folder contains the WordPress data for this WordPress application. All the pictures, plugins, source code, custom code, and videos, whatever else you add into the WordPress application, that will typically go in this location inside the container, but you don't want it to go in there. You want it to be away from the container. And that's the location that I have chosen. And so as a consequence, you see that in this location, when I start, say, cd docker files, and then open up Atom in that folder, you will find that I have that folder separate. Like this green item here, WP content. It contains all the content from my WordPress application. You will also remember one thing, which I think I may have mentioned a long time ago, in case of description of what containers are, that I described to you that these things are layered file system, right? if you remember the discussion we had about the idea of having layered file system. So let us understand that in the context of what I just said. So we have the idea is layered file system. And so anytime you have the actual OS, you want to create something, for example, the WordPress container, which requires, the requirements are Linux, Apache, PHP, and MySQL. So you want to have a MySQL container also, which requires basically Linux and nothing else. No PHP needed. Apache is needed. So you create a layer with Apache and then create a layer with PHP and then put this WordPress on top. Then it gets Linux, Apache, PHP, and WordPress. You already have Linux here as the OS. So you add MySQL on top. So it gets you MySQL container. And then you connect these two guys together. That completes the LAMP requirement, LAMP. And so this container, if you look at this WP-content folder that I mentioned earlier, where WordPress stores its data, I would like to bypass the layered file system. Bypass. And I can bypass the layered file system by creating a volume mapping like this, -v, and some location in the real OS. Map this as a WP-content. Map it to the WordPress location where www WP content. So this WP content is mapped to this some location WP content. And by mapping like this colon indicates mapping, volume mapping. What you're really doing is bypassing. You're bypassing the layered file system and putting it right here on the Linux OS directly. And thereby, you don't worry about all these layer changes. They might change. These layers might go away. The data is still sitting here, which is where this location is. So that's how you bypass. And the -v volume mapping is a way to bypass your layered file system. That's the core. That's how you should think about these things that I described. Let's go into complex examples now. So I am again adjusting my screen and looking at the example. What I am going to do is now take on this main examples, this longer Docker compose YAML file -main examples. That file I would like to take up. This file is sitting in our location right here. So this main examples file is what I will be taking up. I have this Docker compose YAML, which contains this structure. So I would like to remove all those things that are running currently in my machine. I might have them running, so I want to clean them up. So I'm basically doing Docker PS and see what else is running there. There are a bunch of guys that are, I have some exited containers from a reboot. So I would like to clean that all up. So basically cleaning up right now. There's a cheat sheet for these things. I'll point it to you in Docker. You can know how to remove everything. And I'm just using that cheat sheet right now to erase all the running containers. I just are dead containers. So now I have Docker PS showing nothing, and that is a good place to start. So now I will also clean up a couple of things here. For example, this WP content not needed anymore. It's a different example, right? So I'm going to kill it, and I will now. Okay, it needs to be root. So I'll go kill from here. So I killed it. Now I want to take this main example and select it all, and then put that in place of the smaller example we tried the other day. So this will go away now, and delete, and place the other full example, which is quite a bit of things in there. You will notice that what I'm doing here is basically this name, this name, Docker compose YAML, that's the file name used by default. So when you say Docker compose up, that file is picked up by default, this Docker compose YAML file, and others are example files. So we are now looking at the main example, but we have taken the content from that file, put it in here, so we can play with it. So now let's begin from top. The first thing you see is a reference to this Nginx reverse proxy. And so I am not going to assume that you know what a reverse proxy is. So I will describe that, unless you tell me that all of you already clearly understand what a reverse proxy is, in which case I can skip. But I need to know that. I need to know that you already know what a reverse proxy is. If that's the case, please tell me. And I'll skip. But I want to describe the first thing that we'll be using is a method to consolidate a bunch of things together in form of one endpoint. So what typically happens is, in the context of a cloud where you have multiple machines, M1, M2, M3, like that, and lots of them, in each of these machines will operate together in form of what I call a cluster. And they will become a cluster, and they will share load. They will handle container workload. So I have this container workload that I want to put. Container workload, a bunch of containers, like hundreds of them, sometimes more. And I want to put this workload on top of this cluster. So now I'm not dealing with individual machines, M1, M2, M3 like that, but maybe any number, n number of machines I have in that cluster. And I'm going to put my container workload on top of the cluster. That's how I typically operate. And that's the common way of abstracting out these machines, because we really don't care at the machine level. Machines can come and go. Our containers is where we run our workload. So we want to treat the whole collection of machines as a cluster. And so this cluster runs something, a bunch of containers inside. They may be machines, but M1, M2, we don't really care about machines as such directly too much. We care about our containers because these containers run our services for us. So we can have people visit and access. So the scenario that I would like to now do is I would like to have 4 containers, 3 or 4, maybe, like C1, C2, C3, C4, like that. Some 4 containers I have, and I have only one IP address. And to begin with, only one box. So one box running 4 containers and 4 different services, 1, 2, 3, 4. And I want to run a variety of different applications here, not just WordPress, but something else and other things together. I'll also run some corresponding databases here. And they will have corresponding databases to map to. And I would like to have sometimes run a complex setup. But that's what this example actually is going to be like. So I will have one box running a bunch of different containers. And I want to access this box by each of these applications running in the C1, C2, C3, C4 individually by name. I want to call them by name. Hey, your name is C1, your name is C2, C3, like that. So I would like to visit them by http://c1 or http://c2, like that. And by C1, I can have a fully expanded DNS name, such as, a.cloudgenie.us or b.cloudgenie.us and xyz hello.com, whatever else, whatever domain names can be. This can be C2, this can be C3, whatever names I have. I would like to refer to these guys by their actual names, like a fully expanded DNS name, for example. For short, I'm just using short names, C1, C2, C3, which can be equivalent to a full name. So what I want to be able to do is run a bunch of things here, have them share an IP address, and have people ask for C1 by name, and it should get routed there. If people ask for C2 by name, it should get routed here. If people ask for C3 by name, it should get routed here. So this is a device that I have to put in there in front of these guys, where I will have this person or this entity will become conceptually like the load balancer that we had before, if you remember, but not really. Not really. So in other examples, we had people and more people waiting in line for, and they will have a traffic cop, and they will meet the officer number 1, officer number 2, officer number 3, officer number 4, and say, you sir, go here. And this cop decides. The cop decides, right? That's the scenario of a load balancer. Elastic load balancer in Amazon, or HA proxy, or other examples of load balancer that you know. This load balancer, you can also call it as a forward proxy. Forwarding proxy. That's another name you can call this traffic cop, where the cop gets to decide where this guy should go. You go there. That decision has to be made by the cop. Whereas now in the other example, what we're doing is people ask things by name. I want to meet, the application here running by the name C1. I want to visit the application here running by the name C2. And so there is this device called a reverse proxy. That is what everybody will go and ask for. And the reverse proxy, what it will do is intelligently understand, what are you looking for? Oh, you want C1? Oh, let me send you to C1. And you want C2? Let me send you to C2. Even though each of these guys have the same IP address, same IP. Just by the name, if you visit http://c1, your traffic will automatically be routed to this guy. And that automation happens through a reverse proxy.
It sounds like what a router is doing, right?
Yeah, router does network address translation, right? So router is on the other way. So you have, say, for example, people in a home, right? You have people in the home and they want to access things outside the firewall or the router, the private network. So you have a network here. This is a private area. This person wants to go outside. So there is a router here. And what router does, hey, I want to go get to the CNN.com website. So why don't you talk to CNN and tell them that I need to get access to CNN. So what router does is, okay, you want to get CNN? Let me go to CNN and say, you know what, CNN, I am the router. Can you give me something? And so CNN returns back a response. And it tells CNN, I am actually this guy. So it's lying. It's a lie. It's masquerade. It's masquerading that I am this person who wants to access CNN. So show me what you got, CNN.com. And so CNN thinks that the person has come, but actually it is the router that is connecting directly to CNN, not the person, because there is a layer of translation in between, and this masquerading happens. That's what a router does. The same person, maybe another person in the household, will access the router, ask for some other website, like the NY Times, for example.
Yeah, but so even the router has to know like which incoming connections go to which person on the inside, right?
Yes, they remember that this request came from this person, so the response coming back from NY Times will go to the person, not this person, right? Mm-hmm. That's the scenario of a router. Whereas in here, the people accessing are outside. And so that's where the scenario of a reverse proxy comes into play.
Okay, I see. All right.
Right? Now, let's see what reverse proxies are available in ready-made form. So there are many ways to implement a reverse proxy. The best one is to use Nginx. Or you can use HA proxy also in reverse form. So Nginx is the open source application that most of you already know. I think all of you already know by now. And so this is the open source application that you can configure to act like a reverse proxy as well, not just a web server, but also reverse proxy. And so what has been done in the industry is that people have created reverse proxy ready-made solutions, and Barracuda Network sells a reverse proxy, and how to configure Nginx as a reverse proxy, and there are instructions to do all those things, but we don't want to go into all that detail. We just want a ready-made solution using Docker. And so there is the person who created it, and his name is Jason, and he created this thing called Nginx proxy, and that is this image available in Docker Hub somewhere. So it's called JWilder Nginx proxy. That's how you pull it. And so you pull and use it. That's what I will be doing pretty soon. So I'll be using that reverse proxy in this example, which is stored in this location. I'm actually, you can see I'm using JWilder Nginx proxy right there. So this is the first thing that people will hit, Nginx proxy. And I want to use the ready-made image called JWilder Nginx proxy. And I want to map port number 80 from the machine here, this machine. I want to map it from port number 80 to the container inside running Nginx proxy Docker image, this image. That's my first step. So that's what this segment of code will do all the way from first 10 lines. This segment will create a service called Nginx proxy, line number 4, map the port number 80 on the real machine, this one, to the port number 80 inside the JWilder Nginx proxy container, this port number 80 inside container, and this port number 80 inside in the machine. I will also do a volume mapping. This volume mapping I'm doing is what I'm basically doing is the Docker sockets that I have inside, outside in this machine here in the outside location. I'm mapping it to a temporary location inside the container. This is according to the documentation that this guy requires. So if you go look at this JWilder documentation, it'll actually say that. So you'd say do a volume mapping just like that. That's what I have done basically. So pretty much this is the segment that you can see. I have taken Docker Compose from this location. Right there in the documentation for that JWilder's Nginx proxy, it says so. Use it. So I'm using it. That's exactly how I begin. So I'll grab that segment, put it right there. So it's a volume mapping, port mapping, and run Nginx proxy image. And when it fails to run for some reason, just restart always. That's the step I will be doing. So this will basically pull down a image from Docker Hub created by JWilder and set up one container for us. Next, I want to now run a ready-made WordPress created by the original developers of Docker Cloud called Tutum. And this is a all-in-one self-contained WordPress solution, which contains the database also right in there. It doesn't have a separate database container. Everything all included, bad design, don't use it production, but all in one for demo purposes. And that is this container. And I'm going to call it C1. You can call it whatever you like, but the name I've chosen to use is C1. So in a very simple example, what I'm going to do is delete all this thing, keep it simple to the extent I can. And I just have two containers to begin with right there. Nginx proxy, which is front-ending the C1 container, which is going to be a WordPress ready-made solution prepared by Tutum. And I'm exposing port number 80. And I'm using an environment variable called virtual host and giving it a name C1. I can actually name it more intelligently. Like I'm going to say, the C1, you become NewYorkTimes.com. How about that? That's more interesting. And so what just is going to happen when I save this file and run Docker Compose up? Let's go watch it. Docker Compose up. You're going to pull the Nginx proxy image, and then it is also going to pull the WordPress image. Two images, line number 8 and line number 15 will be pulled from Docker Hub, and you will have two containers running. And so let's wait for it to finish. And you will see as an end result, what will happen is you will have this container, Nginx proxy container, will act as the front end, and it will use the invite times label to direct any inbound traffic to invitetimes.com and send it over to the New York Times container. That's what will happen as soon as this thing finishes. So it will take about a minute or so, and then it should finish quickly. And it is right now, WordPress is downloaded, Nginx proxy downloading and finished. It's done doing its thing. So now that it has done its thing, let's understand what just happened. Docker PS, what do we got? It says we got two things running. Let's see that again one more time very carefully. And let's see what we got. So we got a JBuilder Nginx proxy image running in a container, and that allows port mapping from anywhere on the internet on this machine. Port number 80, the machine port 80 mapped to the container port 80. Which container? Nginx proxy. So if you visit port number 80 on the Firefox browser, you will see in localhost, you will see that you are hitting Nginx proxy, which will be nothing, by the way, because it doesn't show you anything. So if you say localhost, you will not see anything. You will say that there is Nginx and the service unavailable because it doesn't know what to do with your localhost name. It doesn't understand the name. Localhost, I don't know what to do with it. So I can show you my Nginx temporarily unavailable page, but it doesn't actually show you what you expect to see, because the expectation you might have is to see WordPress in the name New York Times, and that is correct. That is exactly what will happen if you go and visit newyorktimes.com. So I will visit newyorktimes.com, and I will actually land up on newyorktimes.com because the DNS name points to New York Times. That is also correct. But you're looking at New York Times right now, but I want to now actually change it. Change what? Change my zone, my DNS zone, local machine zone, which is this file, host file. I would like to change it.
Hey, Nilesh, I don't think
and make the
Nilesh,
yes.
I don't think we can see it. Oh, there we go. Okay.
What just happened?
I couldn't see. We couldn't see the file, but now we can. So.
Okay. You were not looking at the host file reference that I'm talking. Even this section, you're not able to see.
No, it wasn't showing up at first, but now I can see it.
I see. Okay, maybe some lag somewhere. So if that happens again, tell me that it happened. And what I'm going to do now is edit my host file and hack it. You know this hack, right? What I'm doing is hacking my local machine and making it believe that newyorktimes.com is right here, localhost. You know this hack, right? I just made that hack by adding the name newyorktimes.com and pointing it to localhost. So now if I open my browser, again, go to nytimes.com in a new tab, nytimes.com. What do you think it will show? It will go show me the localhost IP address, but Nginx reverse proxy will understand that you want to access the thing inside, right? So right now it is showing me cached version. I will have to refresh and probably have to clean my cookies because I shouldn't have opened New York Times to begin with. So let me clean my cookies after I clean this up. And cookies, go away, please. Okay, privacy, clear your cookies, all of them, everything. And all offline data and everything just go away. That's great. Now that we have cleaned up, we should visit http://nytimes.com. It will automatically forward the traffic to my local machine, and there you see WordPress. What just happened? Let's figure it out. What is happening? Let's go see. So you see, I hacked this nytimes.com in my host file and make it believe that I am running newyorktimes.com in the local machine, where I have in the local machine, I have this thing running, Nginx proxy. And Nginx proxy knows that there is a container called this guy, which needs to be shown when somebody asks for this virtual host, nytimes.com. And therefore, when I visit nytimes.com, I see this container, line number 14, all the way through end. Now, is that concept clear to you, what I just did?
Is the reverse proxy running on your local host?
No, reverse proxy is running in the container here, separate container.
Right. So when you type in NewYorkTimes.com to your browser, how is it?
It goes to localhost.
Okay.
Right? Let's see it again. See it again. Make sure it is clear to you so that you understand this hack is somewhat difficult to digest like immediately. So let's go read it one more time before this is purely a hack right now. Right now it's just a hack. But to demonstrate a subtle point that how proxy operates, this Nginx proxy is the first thing that the browser is hitting because of the very first line in the host file in the upper left corner. Upper left corner, first line, localhost, nytimes.com. That's a hack. It makes my machine believe that nytimes.com runs locally right here, right now. And so it tries to go to localhost. And there, Nginx proxy sees that somebody's looking to get to nytimes.com. And I know nytimes. It's right here, man. Come on, that's the container. So I will show them that container. That is what is going on right now. I see that container running to.
Wait, so my gap in understanding is how the Nginx proxy, I guess, knows.
Nginx proxy knows that it is nytimes is running in line number 14 all the way through the bottom.
No.
Because of the environment variable.
So if the reverse proxy isn't on your local host, how does it get that route, that connection?
So reverse proxy is running in this container, and that port number 80 is occupied by the real machine, this 80. It maps to the proxy host, Nginx proxy port 80. The real machine 80 maps to proxy 80.
Okay.
And that's why proxy kicks in. Proxy says, oh, you want nytimes? Let me give you nytimes. What is the virtual host? It is this container. So I will show it to you, what I got in that container. Since that port is exposed, I will just divert my traffic to that container, just like this. So here, up until now, what we have done, let's go see that. What we did is we said, you know what, get me a proxy container, reverse proxy. And it has the port number 80 inside the container that is mapped to the machine. Machine port 80 is mapped like this. Then I also have a container running WordPress software, but I call it nytimes.com as a virtual host name. It's a name. It runs some WordPress image. It also has port number 80 open, but not mapped. You will see there's no mapping, it's just open. It exposes itself. Exposed. This is a mapping. And this is a port mapping. That's just a port exposure. So now, when you have a person on this machine attempting to visit this port, by the name localhost, you see nothing, like 503 error. But when you have another person visiting the name nytimes.com, you see that this machine understands that this IP address that you have actually goes directly like this to this port number. So reverse proxy kicks in and shows you nytimes because the name nytimes is in a virtual host format in the environment variable called virtual_host equals nytimes.com in the Docker compose file. So that name gets picked up. So it knows that this virtual host is actually running here.
Yeah, I think I understand everything past that. So are you on that machine? Is that machine the one below right there?
Yes.
Yeah. Is that your CloudGenius workstation? Sorry if that's a stupid question.
Correct.
Oh, okay.
Correct.
That makes sense.
Yes. We are running right now all on the CloudGenius workstation, just like that.
Yeah.
So
okay. I got it.
So this is the CloudGenius workstation. Okay. So now let us see if you try to update that and remove that DNS name from here. If you remove that and call it, say, C1, let's call it C1. and I'm going to save this. And so now you'll see that I have double names. I have a name called C1 as well as nytimes.com. I will put this name C1 right back as it was, and I'll call it C1, right? Save it. And then run my Docker Compose one more time. You will notice my host file contains the name C1 right there, in addition to nytimes. So double naming, but I will run my Docker Compose one more time. So it will pick up those new changes. And it says, I cannot find this nytimes anymore because that is orphan and that is expected. But now if you go to the website and try to go nytimes.com, it will say unable to show, nothing available. If I have to clean up my cookies again, apparently. So I will clean up my cookies one more time. And privacy, clear history, all of that goes away. All of that goes away. And then I open nytimes.com. It should not show me any, it still shows me anything. Why? It should, oh, I have that host file entry. I need to remove that. I need to remove the nytimes from there. That one, that goes away. So now I have just C1. I will Docker Compose up again and go to the browser, clean my cookies one more time. And now if I visit http://nytimes, I should get to the real nytimes, which is what I'm expecting. Apparently not. Okay, so I need to maybe a complete cleanup of Docker, I think. Docker rm-f, Docker ps-aq, complete cleanup. And now let us see if I can visit the real nytimes.com, which I should. Yes, I do that. And a complete cleanup and then start Docker Compose up again, which has no reference to nytimes at all. So I should continue to see my New York Times just like I expect. And localhost should show me unavailable, temporarily unavailable, because localhost is not an understood phrase. However, the phrase C1 is understood. http://C1, that phrase is understood. So we'll go try to see it. It will show me WordPress for the name C1. That's because of this name C1 as a virtual host reference. So that was a quick look at how we are playing with our DNS naming and reverse proxy. Now let us expand this game to a slightly more complex example. I will erase all this I have and then put that full example back in place, like where it was, and put that in the Docker Compose YAML file. And I will also do a complete cleanup on Docker like that. And now I have a more comprehensive example here. Let's go quickly review that example itself. And you will see that in this example, I have the reverse proxy, which begins line number 4 all the way through line number 10, like this. Then I have a image called C1, which runs Tutum WordPress. If the name for virtual host is C1. Then I have another WordPress image. This name I'm using is called virtual host C2. You can see that C2 name here, line number 30. You will see in this example that I have included the previous exercise the other day inside this example already. The entire example of a C2 WordPress image that is linking to a database image, running the database container, just like before, and also putting its data in a data container, just like that, where I would like to build the data container. And then I have additional containers, for example, C3, which runs a different application called Joomla, which is another open source project similar to WordPress content management system. This image is Joomla. It's also available on Docker Hub. It also requires a database. So I'm linking a database, this database here, same database I'm using and making that link to this database so that I can use the same database to store data for MySQL, data for WordPress as well as data for Joomla. So I'm sharing the database in this example. Then I am using a different application called Redmine. This Redmine application is another open source content management system that needs another database called Postgres database. And so I need to use Postgres database, which I am putting it right here. I'm using a library image called Postgres and setting 2 environment variables for a user and password, and using this database Postgres for Redmine, which is required. So Redmine image, I'm using ready-made Redmine image under the name C4 virtual host. And that C4 virtual host is just a name that I have chosen, C4. You can use whatever name you like. It links to the database Postgres PG, but calls it Postgres internally. So you have a name PG, which is a different database here. So you're using it, connecting it to Redmine application so that Redmine also runs in the name C4. In the name C3, we have Joomla running. In the name C2, we have a different multi-container WordPress running. And in the name C1, we have a single container WordPress running. That's what we will have when we run this composition. So we'll run it. Docker compose up. And it will do exactly what we just discussed. So it is doing it. It is going to, first of all, pull things that are missing. So like, for example, Postgres is missing, so it is pulling it right now. Postgres container is coming down. Joomla is coming down. Redmine is coming now. And so these images are necessary because our Docker compose file requires it. And once these images are available locally, it will construct this architecture that we have in mind, which is, I'll draw this in a pictorial form also. As soon as this run finishes, I'll go back to my OneNote and draw out what we just did so that you will exactly understand how do you put multi-container setups together and assign various names, run them all on one box, run them on multiple boxes is the next exercise. So we'll get through this first, and then run a multi-box, multi-container setup also. So here, what you're looking at is Docker ps-a. We have a bunch of containers running. First of all, we'll see that there is a Docker file data container, which runs true, does nothing, and it exited already. That's the place to store data for our WordPress database. That WordPress database is this one. This runs your MySQL image. And it is up and running. It exposes the port number 3306, but again, it doesn't map anything. Only mapping is this one. This is the only mapping. All others are just expositions. We're exposing particular ports. For example, 5432 for Postgres, 3306 for MySQL, 3000 for Redmine, 80 for Joomla, 80 for WordPress. And this is a multi thing. So it's a combination image. It has WordPress running. It has MySQL also running in the same container, which is a bad design, as you already know. Putting multiple things together in one container is generally a bad practice, but it's a good demo. So that's why we have it there. In that example, it is not supposed to be used in production, by the way. If you want to use production, you go like this: WordPress separate, MySQL separate, and disk outside stores your data. Not like this. In production, you don't do like this. In a VM setup, it's good to play with. But right now, we have this setup working and functional, except we still have to do one more thing, which is the hack. The hack will enable C1, C2, C3, C4 names. And so that is what I'm going to do right now: C1, C2, C3, C4. I'm just adding these names so that I can play with it. The alternative way to do this in a real life is to go to your DNS control panel and put proper machine DNS names instead of C1, C2, C3, C4. This is more like a lab exercise in a virtual machine. So that's why I'm locally hacking my host file as a proxy to changing real DNS values. So now I can ping C2 and ping C3 like that. You'll get the point, right? I'm basically pinging localhost. So it is pinging correctly because of the host file hack. And now let us open my browser again. And I will refresh my cookies one more time. And then I will visit the New York Times. Can go away. I don't need it. So I'll visit C1. I'm expecting C1 to show me WordPress, which is already doing it. So it did not, because I did not type properly. I should type http://c1. And so I should see WordPress, and there it comes. This is the Tutum WordPress, the first example. Next, I will open another tab and type C2. And in C2, what do you expect to see? Another WordPress, right? The C2 is exposed on this virtual host called C2, which is here. And it is exposing the image called WordPress, exposing port number 80, and is mapping to a separate container, the MySQL container down below in line number 39. At 39, that container doesn't actually expose itself on port number 80, so you cannot get there, but it is accessible to this container because of the link relationship here. So that link will allow this WordPress container to connect to the database, and therefore that is why you see C2 showing you WordPress also. This WordPress is different from this WordPress. This is the C1 WordPress. This is C2 WordPress. And you can prove it by making sure to set it up. This is, I'm going to call it C2 and give it a name. And that becomes my C2 login. And you can see that this is the C2 setup. So it should show you that I am C2 somewhere here, C2 right there. And in here, you're still stuck with the first step. So you can proceed and finish it off with the name C1. You can give any name you like, but I'm just giving the names C1, C2 for simplicity. So now I have both these separate instances of two applications by the name C1 and C2, both running in different containers, but you will see that this one is a stale image. It's old, and it is also considered to be not ready for production. It runs MySQL database in the same container as the application WordPress, which is a bad idea, and therefore it should not be used in production, but it's there, C1. And this is C2. It looks different. It's a different version of WordPress. So we got C1, C2 going. Let's see what we get in C3. We are expecting, not this. I'm not expecting service unavailable, but let's see what C3 does. Joomla. Okay, Joomla, did you start? Apparently Joomla had a problem running, it seems like. Come on, Joomla. No, it doesn't want to run. But let's see if we can see other things like http://c4. What do we see? It shows Redmine running. So that Redmine thing is running on the name C4 and is running actually in our line number 70. 70 through 77 is the Redmine container, which links to a Postgres database, which is also running here. So now let us see what we just did. I'll put this on one half of the screen and attempt to draw it pictorially so that we have a good idea about what we are dealing with. And here it goes. So let's see. We began with the very top. So the user comes in here. User. The first thing the user sees is they will ask people or applications by name, C1, C2, C3, C4, like that. That's what they will ask things by name. And the first thing they hit is the IP address, which is just one IP address. In this example, it is the 127.0.0.1 IP address. And there on port number 80 is mapped to a reverse proxy port 80. So this Nginx proxy kicks in at that point. And then it decides, okay, what do you want? C1, C2, C3, C4? I will give you exactly that, whatever you ask for. And underneath you have C1 running, which is a multi-application single container running WordPress and MySQL and everything else, all self-contained and a bad design. But a quick example of a bad design. That's how I would call it. That was the two-tomb WordPress image. That's what you see here. The C2 that you see is actually also on the port number 80 on this container. This is port number 80 on this container. And this C2 is a WordPress image, which is a recommended approach to running WordPress. This is the library image. It connects to MySQL container running MySQL image, which is also a library image and a recommended approach to running. It exposes port number 3306 so that this container, WordPress, can talk to the database. Now this thing stores its data in a separate container called data container, which in a real cloud setup, you should use a disk, like a Google disk or a Amazon Elastic Block Storage or something similar in other clouds. Every cloud will give you proper way to store stuff. I don't have a disk to connect to in this virtual machine, so I am using this dummy proxy. Next, I had a C3 container running Joomla image, and it requires a database. So I used the same one. And so for some reason, it did not work, but we can deal with that later. Or maybe not at all. You don't have to dig around as to why Joomla did not run, because that's not the point. Then we have C4 running another application called Redmine, which opens itself to port number 3000. And this reverse proxy is smart enough to detect that the port 3000 needs to be connected to. From 80 to 3000 is a detection reverse proxy will do already, and map your traffic already for C4 will automatically go to this container. And then this container expects to connect to port number 5432 in a separate container running Postgres database. So that I have used another container, which is this container, which runs the Postgres image. And that is what is a library image. So we want to use that as a database for Redmine application. So people who want to visit C4 will go to the IP address, port number 80, will connect to the reverse proxy. Reverse proxy will decide that the traffic needs to go to this box. Sorry, why do I say box? I should never say the word box, because there are no boxes. It's all containers. So it goes to that. I'm still switching my mind from using the word box to using the word container, because the world has changed. People don't use boxes directly anymore. But I still use the word box for some reason. So that's a stupid reason.
It's because box is a container.
Sorry?
Well, literally a box is a container.
I did not understand. Can you say again?
A box is a container. But
I know.
literally.
Yes, you're right. A box is a container. But then, if you go to the definition of it, you will probably, be able to debate on the topic of container. What is a container? Maybe a container is something like the container store gives you, right? This container store, that's a container, right? But I'm digressing. So let's quickly take a look at the container store containers. And these are the containers, right? These are the containers, lots of different types. But back here, where is that? here. So in this picture, we were able to arbitrarily connect a bunch of containers in a fashion that we would like to have run 4 different applications. Sorry, I should color it. And so 4 different applications we have here. 1, 2, 3. We did not work, but 4. 4 applications all mapped through one common reverse proxy, and have people visit these guys by name. And that's the function of a reverse proxy that you saw. Back in our virtual machine, we have that thing going and described succinctly in form of a Docker compose YAML file, which looks like this. And you have it already. You have that thing running, except Joomla. But I don't really care about Joomla anymore. I never cared about Joomla at all to begin with. But
Nilesh,
yes.
question. The C4 connected to the PostgreSQL database via port number 5432 or whatever.
Yes, correct.
That's just the default port?
It's the standard default by Postgres. So if you can go here.
Okay,
yeah,
got it.
Let's go see. Let's go verify that. I want to make sure that I don't give you wrong information. But Postgres standard port is 5432. Yes. And so the Postgres documentation says it is 5432. You can change it if you like, but the default is this. And that default gets picked up because the image underneath, right? Let's see, Docker image Postgres. That Docker image Postgres is what we are using, this image in the Docker hub, which is Docker pull Postgres. So under the hood, you will have a Docker file, right? Where is the Docker file? Right there, this one. So let's go see the Docker file. The Docker file will describe what is going on. So it's a Debian-based product, Debian Jessie, and you're installing Postgres SQL Server in there. So you're installing the PG major version number. You're downloading that echo deb. So apt-get update and install Postgres SQL major version number, and then contributions to Postgres. And then you're removing unnecessary stuff. And at the end, you're exposing port number 5432. So that is what is going on. Excuse me. Excuse me. Excuse me. That is what is going on in the container itself under the hood, because that's what we just saw in the image. The image is, excuse me, I think I need to go grab water or something. But this Postgres Docker file you're looking at actually describes you exactly. So that's the beauty of open source. You can use anything you like, but you have the ability to understand what is under the hood. So you can always go back and read what is going on under the hood, like we just did with Postgres. You can do similar things with Redmine. So let's give Redmine a ready-made image. And this is what we just used, but let's see what is under the hood. We can see that it uses this Docker file, 3.3 is the latest. So this one, and we can see that the Docker file that we have for Redmine uses Ruby as the foundation. And then it installs, creates a user, updates, and then sets a bunch of parameters, sets more parameters, and update, installs a bunch of packages, and then runs Rails. And then Redmine is a Rails application. So you have that Redmine downloading from here. And then it is going to build the dependencies needed. And at the end, it will run this file Docker entry point, which will basically lead to Rails server running on any location and exposing port number 3000. That's what you saw in this illustration, port 3000 for Redmine. So I think I will take a short break and then come back to do a multi-container exercise in terms of basically generalizing what we just did. So in our example, what we have is this set of examples we played with. There are more examples for you to play with if you want. There are other examples also. And you can play with it yourself if you like, and you can modify the way you want. There is, I think, Drupal added, and so C7, C6, and C5, and a bunch of other things I've added here. But you can always modify it and play with as you feel like. In that's just another example. But this is all running inside one box, which is different than what we will do now in the next exercise, which is going to be multiple boxes together, playing together.
Hey, Nilesh, last question before you take off on the break.
Yes.
What's the practical application for running all these containers on a single box?
Practical application, you want to see that?
No, not necessarily see it, just like discuss it. Like why have all those containers on a single box?
So small businesses are a good example, and a real life example is right here. I run about 13 containers in one box to run a bunch of services, including this site.
Oh.
And it is going on live for many years. I've been doing this, and I've been evolving it as technologies grow in one box, and it runs live for $10. You would not believe me when I say that, but $10 per month is what I pay. And so I'm logging in, showing you real life example. $10, cannot beat that. Nobody can beat that unless you know these tricks. And so I'm going to just grab my token and put it in there and show you real life 13 containers running. Number is 246719. Here is the guy. It's called, I have named it Chromebox, but that's the IP address. That's what I wanted to grab. So that's the IP address. Only one machine running here in production. I'm going to copy it. Now I will minimize this thing, and I will connect to the machine directly. How do I do that? Command line. Oh no, bash prompt. I have bash prompt loaded in Windows for a change. So there we go, bash prompt. Let me see if I can make it bigger. Yes. SSH root at. Hey, why do I need the IP address? I don't need the IP address. I can just go like this. And oops. So SSH. I don't know how to use SSH on Windows apparently. So I get into oops situations. Okay, so now I'm connected to production. You can see that this IP address matches my DNS IP address. If I can ping be a cloud genius, it is the same IP address that you're looking at right now. And so I'm going to break from it and come out of it and confirm that it's the same machine. And you can see that's the same IP address ending with 228.239, the same one. Now let us connect that machine again. So here we go. And then we'll see Docker ps-a. And what do we see? Huge number of containers. Let's see, count them. Let's count them. So these are the containers I'm running. And I have a data container. You can see that I'm running a data container, just like the example I showed you. And this is because in older days, like about a couple of years ago, maybe 2 years ago or something, that there was no disk storage solution. So I created my own solution based on the data container I just showed you. And that is highlighted line is the data container. This WordPress application running in a separate container called Cloud Genius WordPress as opposed to library WordPress. So my own images, slight variations. I have a MySQL container running. I have another MySQL container running for a different application that runs in the background, runs analytics. That is this PVIC application. It's also open source. I have a Nginx server running to support the PVIC application. I have a Let's Encrypt companion running to get me HTTPS SSL certificates. I have a Redis database running to speed up web browsing experience. I have a bunch of redirect containers running to transport access to, I'll describe what that thing is by example. Then I have a site running here, which does nothing but invite people to Slack chat. It's called chat.cloudgenie.us. And this thing runs this site. And so anybody can come and join Slack chat through this site, which is just a simple service running JavaScript. And that is a separate container you can see running here. And there is an Nginx proxy also running, of course, which is what you just saw me run in a live example. And that Nginx proxy will do proxying between the Pivot Analytics, between Cloud Genius WordPress, between all these bunch of containers I have that are basically representations to a variety of things, such as if you type, instead of typing BA Cloud Genius, just type www.cloudgenie.us. It automatically routes itself to the right location. If you also type something like HTTP without the S, it will automatically go to the right location. If you type something like, let me say, cloud emoji. Let me show you a fun example. That will be interesting. So here's the cloud emoji. I'm going to copy that emoji. And so here I copy it. And then I open a new tab and paste it cloud.ws and enter. And you will see that it also goes to the same site. This cloud.ws is a DNS name that I have that takes me, and you can see this name cloud. Where is that? There is one of the containers that redirects that. That should be here. There it is, cloud. So simple containers that I have running, about 13 or so in one box, is a small business solution. It doesn't necessarily apply to a large business, because in large business you will have multiple boxes, and that's what the next exercise is going to be. So in addition to this, by the way, there's this entire creation and deployment of this setup, a multi-container setup, including its backup and restore, is done through Ansible, which is a separate exercise. If you are interested, we can walk through, but it's more tuned towards small business usage. It's not meant for large businesses like Boeing and IBM and Microsoft. So if you're interested, I can play that exercise for you separately. But right now it's time for a break, and then we begin a complex multi-container applications with multiple machines going in real clouds. And by real cloud, I don't mean actual cloud by Google, which you must have. You seen that actual cloud by Google? Have you?
No.
Yeah, it's funny.
You should see that Google actual, search for it in the break, Google actual cloud, and watch that video while we are on break. Watch that YouTube video. It will be fun. So I'm going to start a timer, 7 minutes. Google actual cloud. That's the name. It is fun. It's different from real cloud, by the way. Let me go grab water. I'll be back. Hey guys. Are you there?
Yep.
Yes. So let's begin. I will describe some of the concepts and then begin doing examples to help us get to multi-container, multi-box situations. And that goes something like this picture I'm going to draw. So bringing up that sheet of paper again and beginning to draw on maybe that page. Yeah. And view 100% and grab my pen and describe. So a multi-machine setup is necessary, absolutely necessary in case of large business or even medium business. Like small businesses can get away with what I just told you in a one machine setup. But most cases of medium to large businesses will require a comprehensive, complex setup that requires basically multiple machines. So you will have color. You will have M1, M2, M3 like that. N a number of machines created together in form of a cluster. This idea of a cluster, and then you have a bunch of applications. You will describe them in form of a stack. Essentially something similar to the Docker compose.yaml file that we had before, except it will be a slightly evolved version of the same thing. But you will have multiple things running described in a simpler fashion in another YAML file. Let's call it, for now, a stack YAML. So you describe another YAML file, which has lots of things, bunch of descriptions inside one file, and you throw that YAML on, say, here, go, run it for me. It will intelligently run all these segments that you have inside in the stack, in the stack.yaml file, appropriately schedule containers here, wherever it is needed, sometimes multiple containers on the same box, sometimes just one container per box, depending on whatever your scheduling policy is in the stack definition that you have put together. That's the way to think about this idea, which I am calling it a cluster of bunch of machines. And then Docker calls it Docker Swarm. Just to confuse everybody, there used to be a Docker Swarm product before that has been revolved into a new name called Docker Swarm Mode, and that the old product Swarm has gone away. And so now everybody is using the name Swarm for the new product called Swarm Mode. That's what people generally talk to, but those of you who are new to Docker, you don't have to worry about the history, but just want to make sure that you don't get confused. The bottom line is to use the latest version of Docker, which supports Swarm. I think it is the version 113 or maybe something like that. But right now we have latest versions of Docker are, I think, 17 or something, 17.3. So they bumped the version numbers straight to larger number as they transitioned into a community edition and an enterprise edition of Docker. So that transition has happened, meaning this is going to be money and this is going to be open source free. It is the same product, by the way, but some additional services that Docker provides. So this is the enterprise Docker. Don't get confused by the fact that the name is enterprise. It has no meaning to it. It's the same product. So it's the same open source product that you look at here, that you go to GitHub and find Docker. That's what the same thing is, except some additional services are paid for. So you have to buy those services and you pay them money, and that's how they make business. That's a good thing. Let them do it. We will focus on open source. So we are going to use open source Docker, and we will have to have these machines M1 all the way through MN. These machines, they need to be set up with Docker, right? There are a variety of ways to do that. The simplest way is to just go here For example, any cloud, start, and then say in Seattle, give me an application. Give me ready-made Docker, please. And choose the size you want. And choose your key you want. And then you give it a name. I'll give it name M1, M2, like that. And that's one way to deploy this manually, which is boring. So, but that's one way. So any cloud will give you this method of ready-made Docker-based machines for you, which you can have constructed M1, M2, and M3, and they're independent machines, by the way. So you have to somehow make them work together. They need to become a cluster. They need to become aware of the existence of each other. That M2 needs to know that there is a thing called M1 and M2 and M3 and M4 and Mn. So that connection in between among themselves needs to be established. And that is a step that we had to do. It's a one-time operation that these machines will discover each other and then become a cluster, a shared pool of resources that we can then deploy our YAML file on top. And so without that, it is just a bunch of machines disconnected, M1, M2, M3, like that. But they don't know about each other. So we have to go make sure that you connect together like this. And so everybody needs to connect to everybody else. You get, it's a complete mesh that you have to create. And that mesh creation is very simple. And Docker Swarm does it for us. So we'll play some examples on that. Having a swarm ready, we will be able to run, or rather I should say deploy, a stack.yaml onto the swarm. And when we do that, inside you will have all the things that you expect running, and you can just access this IP address of any of these boxes, M1, M2, M3, any of these boxes. You can just access the IP address of M1, M2, M3, or any one of them, and you get to see and use whatever the stack shows you. It doesn't have to be just one of those boxes, but any of those boxes will participate in a load balancing network. This is by design inside Swarm. It is known as the Docker ingress router. Docker ingress router. It is there by default in the latest versions of Docker. And what that means is that if you have, say, M1, M2, and you deploy a stack, the stack will automatically stand up in containers inside those two boxes, and these have IP addresses. And you can make your DNS entry, a record, map to these at both addresses. And whichever is available, whichever is the first one, whichever is the nearest one, whatever you choose, it will automatically get picked up, and your stack will show up to this user who visits this IP address, this A record, this domain DNS record. It will just automatically pop up and show you the stack. That's the design behind this ingress router. And that's what we are beginning to discuss is the concepts behind Docker Swarm. And let's see if I'm missing something that I want to describe conceptually before I begin exercises. So here, I think you understand this picture already. There is underlying infrastructure. There is a hypervisor, and then you have guest operating systems. This is a classic situation of a virtual machine deployment. And this picture they showed you here is a container deployment where the underlying host OS is common. This underlying host OS is common, and you have a layer of Docker running, which allows different containers, A, B, and C, running binaries and libraries and whatever you have. But the underlying infrastructure begins basically by making sure that you have Docker everywhere on all your boxes. And to get that, you can either like get a machine that has Docker already. Like, for example, I showed you this example here. So you go to a location, say Sydney, and select the application Docker ready, and that's you deploy. That's one way. The other way is to use the exercise we had in Ansible, where we convert a given machine into a Docker host. So if you remember a previous exercise in Ansible, we took a machine and we ran the Ansible playbook. And that Ansible playbook, it converted this machine into a Docker host. You can run it that way. But there is a third way. And it's in the open source, you will find that you can choose your way you like. There's nobody preventing you or limiting you from doing a certain thing a certain way, because it's really up to us as to what we want. And so all these methods of standing up infrastructure to run Docker is up to you. You can do it manually. You can use Ansible. You can use Chef. You can use whatever you like, or you can use the Docker way of doing it. The Docker way of doing things is called Docker machine. And what this tool will do is run some command line and say, Docker machine, start something. And so it will basically start a machine in some cloud and make it Docker ready and allow you to connect to it also. So that's a nice little tool, runs on command line, and you get it when you have. Let me exit out from here so I can then play some live exercises as I talk about it, and then follow along. So here I am quitting from this and quitting my regular bash terminal, which I am playing with. And I'm going to start regular Windows. How many of you here in this group, by the way, are using Macintoshes right now? Just checking. Or rather, not using Windows. That's the way to ask. How many of you are not using Windows? Anybody? Nobody? Nobody's not using Windows? Justin. So Justin, I know. Justin, you are a Mac person. I know. Okay, got it. So Justin is a Macintosh person. So stand by, Justin. For right now, I am playing some Windows-specific exercises for a change. Very, very strange change from me, but I am running Docker right here, right now, directly on Windows. That's a crazy thing I'm doing, but I'm doing it. It's running. It seems to run just fine. So I have installed Docker locally directly on my Windows box. It is running Docker for Linux. This is the default mode of running Docker on Windows, is that it runs Linux containers. You can change it if you like. You can say right click and say switch to Windows containers. So if you switch, it will restart the whole Docker setup and allow you to run Windows containers, which of course requires Windows and runs Windows. What does that mean? Your underlying OS becomes Windows. And if that's the case, all of these things inside will be Windows. And then you cannot run Linux. No Linux in there. Not possible. Right now, by default, if you deploy Docker on the underlying Windows OS, but the default mode of setup is that the underlying operating system that you receive, where you install install Docker is actually Windows, but then the containers you run are Linux. That's the default. That's what you see here. On the default, Docker is running, and when you right click, you see the option of switch to Windows containers. And I just accidentally clicked that button, which is a bad thing because Docker is switching right now. I shouldn't have clicked that button. And so it says container features are not enabled. Do you want to enable it for Docker to work properly? I say no, cancel, please. And so I want to stick to my Linux setup. I don't want to modify it. I hope it does not force me to reboot, which will be a bad thing. But let it finish stabilizing. And when you do that, you get Docker machine, by the way. So as a consequence of this, when you install Docker on a Windows box, you get this thing already. And for those of you like Justin, for example, you can use Docker machine already loaded on your workstation. There is Docker machine right here, by the way. So Docker machine is already included in this. And if you have Macintosh, you want to install Docker machine, you can read the documentation. which is available on Docker Hub and on Docker Hub, available somewhere here. You should have how do you install Docker on a Mac. There is a Docker for Mac, so you can install it that way. And you can use the stable channel, Docker for Mac stable, and this will work just fine for you. And you, of course, will get Docker machine as a part of it. I have set up Windows Docker, and as a consequence, I am running the Docker Windows stable channel, and I am seeing that it is still busy switching. I'm going to switch to Linux containers again and let it finish. While it does, I will be able to use Docker on Windows, as this thing seems to have succeeded apparently. Good. So I'm going to quit Docker and start it one more time so that I don't mess up in an exercise. So I'm going to start Docker for Windows. Let it exit first. Docker is running. And to give you more information on how these tools operate, Docker for Windows uses the underlying Hyper-V capability in Windows. This hypervisor is built into Windows 10 and Windows 7, I think also has maybe you enable those services. Docker will do it for you. So in Windows Docker, they use this hypervisor and run Linux containers on top. In Macintosh, they have a new open source hypervisor that they have been using. In Macintosh, the name is strange and it's a relatively newer name. It is also open source, but I'm forgetting its name. What is the name for it? Well, I'll find out and tell you. I cannot readily locate it, but that's a different virtualization engine than VirtualBox. And for Linux, you use the native ability to run Docker, which is described here. So there's a variety of ways to install Docker on the underlying platform that you have, Linux, Windows, and Mac. And also for Windows Server, they have a solution here. So depending on your setup, you get to a point where you can run Docker on a cloud machine or a local machine or anything like that. So once you have that, you then have the ability to run Docker machine on the command line like this. So on the command prompt, I'm going to run administrator mode, and that is not necessary unless you want to start Docker machines. That's why you need administrator mode. But Docker machine should be installed here. And what this will do is enable us to create those machines, the multiple machines that I'm talking about right now. And so if you want to construct a bunch of machines in the cloud, you can just ask the cloud company, hey company, can you please give me so many machines in your company? I will be using Docker machine to construct, so which requires a method for Docker machine to operate on that cloud company. And only certain companies are supported. They are Amazon and DigitalOcean and Azure and Google and a bunch of others. But not every cloud company is supported in Docker machine. So if they're not supported, sometimes there are third-party support available that you have to add on, like Vultr Cloud has a Docker machine plugin that you have to add manually separately. So if you go back here and see which clouds are supported. So say, for example, Docker machine. Where is that? I think I'll need to Google search Docker machine Vultr. So this is an open source project that enables a machine driver for Vultr Cloud. So it's a third-party driver plugin, but some clouds are already, they have a plugin built into it so that you can just say Docker machine and then create and then use the driver for a particular cloud. So you can say Vultr Cloud or use DigitalOcean Cloud or Azure Cloud or Google Cloud, whatever cloud you have in mind. A Docker machine command will create a machine in your cloud, provided you pass credentials. And then select the OS image you want. So here, Docker machine create using the Vultr Cloud driver. Here is my key that gets you access to, and I select my size of the machine and get me an Ubuntu machine. So it will go and do that for you in this particular cloud, in the Vulture cloud, for example. So you get to choose, you need to choose which cloud you want to play with, and then select that particular cloud as a reference and say Docker machine create, and then use the driver -d option for the cloud name. So this could be Azure cloud, for example. And then you give it a name of the machine that you would like. So it's my virtual machine number 1, for example. So that's one way to operate. The other way to operate, if you're playing around in a local setup, like I am right now. What I'm doing is in my, hold on, where did it go? I jumped. Okay, come on. Okay, in my example, so you can use Docker machine to connect to a variety of clouds and get some machines created. The other way to operate, if you're operating on a local machine, is to select Docker machine to have your local hypervisor create virtual machines for you. In your driver could be Hyper-V. So this is the Windows hypervisor, for example. And for that, depending on your operating location, whether you are in Windows or in Macintosh or in the Cloud Genius workstation, if you're using Windows, it will be something like Docker machine create, use the Hyper-V driver, and you choose a Hyper-V virtual switch, select your switch that you have chosen, and then start one machine. Docker machine create Hyper-V virtual switch, my switch virtual machine number 2. That's how you can begin creating a bunch of machines that you have. And these machines will be created in your local hypervisor on that Windows 10 where you have Docker installed. So that's Windows way of doing things. You're doing everything locally. The Macintosh way of doing things will be Docker machine create, and you use the VirtualBox driver to create this machine and that machine. So you'll have those similar setups constructed like this. If you want to operate in the cloud, you will use the Cloud Genius workstation and use DigitalOcean driver, for example, and create those machines out in the DO cloud. So that's the setup example, initial swarm setup example. Now what we want to do is to actually play around with an example that we had done before and take this in a multi-machine setup. So since I am on Windows, I need to do this thing, which is this step, which requires me to have a virtual switch in place. So I will use such a switch. What I will do is go to my Hyper-V manager, and in there, I will look for a virtual switch manager and make sure that I create this switch for myself. So I need to basically create a new switch. So I need to go here, create new switch, create a new external switch, and click the create button. And I'm giving it a name. In my example, I have given it a name of my switch. That's the name I have chosen, and I have made it an external network, which will basically bridge any connections to the applications to the local area network I have in my setup. So it will basically be outside the VM setup, completely bridge network. So that bridge virtual switch manager switch needs to be created just like that. And once that is in place, you can close out on this window and focus on setting up at least 2 machines to begin with. And that is what we will do. So we will have these 2 machines created called myVM1 and myVM2 in that example, which is what I will be doing right now. So I will have this machine and this machine, 2 boxes created. These are boxes, these are virtual machines that I will be running in my Windows box. So there I have Docker machine. Is it too small? Is it readable what I'm typing or not
Yeah.
really?
Yeah, we can read it.
It's good.
Okay or not okay?
Okay.
Yeah, it's
Okay.
good.
Good. So Docker machine listing, I see that I have nothing right now, which is expected. I'm beginning from scratch. So I'm now taking these commands, and since I'm taking this one, for example, and say, give me Docker machine one of them. So use my switch that I have set up already, use the virtual switch and create a new virtual machine using Hyper-V hypervisor. And so here we go. Paste, please. Please let me paste. Oh man, this Windows copy paste business, I will never understand how it works. Copy, paste. There we go. So I'm going to paste it. And so it is going to do some pre-checks. One of the pre-checks it does is, are you an administrator? And since I am running this command in the administrator window, it will let me create a machine. So it is creating a VHD, and then it will start a virtual machine in the local hypervisor. And then I will have a machine running Linux in there. That will be called my VM2, also my VM1. That is what I'm waiting for, that machine to show up. And I am going to erase some of these guys. Draw and eraser. Why does the eraser not quickly clean it up? Okay. Yes. So as the machine gets created, VM1 and VM2, my VM1, my VM2, I need to mark them, one of them as the master and the other one as the worker. So the idea of a master and worker is basically to designate a leader among equals. There is no big boss and slave kind of setup, but you can have multiple masters, multiple workers constructed, and these masters can get, if one of the masters dies, the other master takes over, and there is a procedure under the hood that works that allows for election of a new leader in case something goes wrong. So the whole cluster is quite resilient from that perspective, and you will see some examples like that as we go along. And now I have the second command I need to go and send, which will start a second machine in my terminal. It is waiting for my host to start, which is kind of lame, but that's what's going on right now. It should not take that long. But if it does, I will switch to the cloud. I don't want to necessarily use a local machine. If this takes like more than 2 minutes, I'm going to basically bypass this idea completely and switch to this idea, is to use the cloud directly. So I'll have 2 machines, or maybe more machines out in the cloud. We'll put that together in form of a swarm, which is the swarm exercise we are attempting to do, and then run a stack that we have played with already. So we have played with a stack before this Redis example that we played with the other time, like connect to Redis and hello, my name is this, and how many times this has been visited. You will see that we have run this Flask Redis example before. This was the Docker file, and this was the application, and we had a Docker compose. So we did this thing already. What I want to be able to do is run that same setup in a multi-machine setup, and it seems to be going forward, which is nice. So that virtual machine number 1 is getting created. And as soon as this thing finishes, I will start my second machine and have 2 boxes ready for me. And then I will play with those in a combination and create a cluster around that. That's my intention. That's what I will be doing as soon as this thing finishes, which is what I'm waiting for. I think I accidentally hit my pen on the microphones. It must have caused a loud noise on you. I'm sorry about that. I don't realize this until I did it, where I'm like tapping my pen on the microphone's head directly, which was a bad thing. Yes.
Hey, I think if you have something highlighted in the command prompt in Windows, it'll freeze the whole, display. That makes sense. So you notice how you have my VM1 highlighted right there in the command prompt?
Thank you for catching my issue. I see what you're saying. I get that. Yes. This is a dumb Windows thing. I understand. I forgot about it. Yes.
Okay.
I know. Thank you for catching. This is I'm a even though I worked at 10 years at Windows in Microsoft, not Windows, but in Microsoft,
Right.
I am a dumb Windows user. I must admit. I'm sorry. I saw what you just told me, and I remember that if you highlight something in like this, the whole command flow gets stuck.
Yeah.
That is stupid. But
that's how it is apparently. And so don't do that. Thank you for catching it. I just realized and I forgot about it. So yeah, sorry. This is the first time in my life that I'm using Windows to run a boot camp. All because my Macintosh had to go. So it went away, my big Mac. But this Monday, they announced a new iMac, and I have ordered it, and it's coming on the 19th. So I will be back on Mac pretty soon. And the Surface device that I have will probably be catching some dust. So second machine. Thank you for catching that, man. That is good catch. Absolutely. Otherwise, I would have wasted more time.
Sure.
Yeah, the only Windows people will know these things. Most people will wonder what's going on, and they'll complain and see, copy paste doesn't work. I hate it. Come on. Machine number 2 starts, and I will walk away from this window because I don't want to click anywhere. Oh, Windows. Oh man. So those 2 machines are running, which is what we are waiting for. And now let us focus on the application itself again quickly. And I want to construct a stack file that I want to give it to my swarm and then have it operate like we discussed, right? That's what I want to do. So in a multi-machine setup. So here I have this Docker file, which I need to have in a folder already. So I am going to open a separate command line, apparently, CMD. And in that command line, I will go to a place where I have this thing already located. And so I'm going to open up a Atom editor in which I have these files already, all the application that we played with the last exercise or the exercise before last. That exercise is already here in this window. So I have my application app.py in that file, which is already there. And I have a requirements file that describes Redis and Flask. I have my Docker file that describes how to build it. So I'm using Python. I'm using setting the work directory as app, adding the current directory as the name app inside the image, installing my requirements, which are Flask and Redis, exposing port number 80, and assigning an environment variable name, and then running Python app.py. Right? So this is what I just did, which is the application itself. I want to now build this image. So I will build that image just like that. I'll say docker build dot. So that image gets built. And it is building right now, which is basically going to pull the library Python image. And then I should not double click ever. Should not double click ever in command line. Okay. And so that is downloading right now. The Docker image is built, and I will use a friendly name tag to this, right? I need to tag it. So this docker build dot will complete building that image after the pull completes. In the meanwhile, the other machine is getting ready. So, which is good. And back in here, I'm waiting for the download to finish. And then it will build that image, which I want to use as my source image for my application. This is a custom application app.py that I'm constructing. And I'm constructing an image. And I'm going to push that image to Docker Hub. You already know the steps. You probably have done this in a previous example. You have pushed your own images. And so that right now, as you can see, the image is getting constructed. I want to tag that image. So I will tag it in the next step, which I should have tagged in the first step itself. So I will say docker build -t, and I'll say Cloud Genius /friendly name :tag, and then dot. I'll give it some tag and some name. So now I have a tag like this: Cloud Genius /friendly name. Friendly name is the image. Cloud Genius is the company name. And that tag is the tag that I use for my particular version. Now here, what it is telling me is something that is like a warning. This is specific to Windows. You don't have to worry if you're Linux. But essentially what it's telling me that you are building a Docker image from Windows against a non-Windows Docker host. So the files will have a read-write permission like this. It is recommended you can double check and reset permissions on sensitive files and directories. So there is a file directory issue that you need to understand, that permissions on files can be different between Windows and Linux. That's what it is warning you about. Apart from that, this image that we now have, which is Docker images, which is the Cloud Genius friendly name with a tag image, is now ready. I can send this image to Docker login and followed by Docker push, something like this, Cloud Genius / friendly name : tag. I can push this image out to Docker Hub. By the way, I have already done this step, so I don't want to waste time in pushing. So I'll break this. And I already have that image out there. So that's how I construct the image using this Docker file. Now that I have that image, I want to make use of it. So I'll define a stack. Stack definition will be something like this. That goes like, I've been defining a service. The service I will call a web service. This web service will use the image Cloud Genius friendly name tag. That image I just created and I pushed. By the way, I already pushed it before. This same image. Using this app.py and this Docker file and this requirement.txt. Create that image, push it, and use it here. So using it right here. And this machine should be ready by now. So 2 machines ready. We can see the Docker machine ls shows me 2 machines. Come on, show me. There we go. So we got 2 boxes running with these IP addresses. These are external IP addresses in my local area network. So I can access these guys directly because it's an external network called my switch that you know already. So now that's the stack with 2 boxes ready, but it is not a cluster yet. We'll get to that. But on that cluster, I want to run this particular composition. I'm creating my services right now. In this service I have, one of them is a web service. That web service uses my Cloud Genius friendly name tag image. And I want to deploy it 5 times. And I want to resource limit constraint to only 10% of the total available CPU horsepower in that situation. 10% max. I want to limit the memory consumption to 50 MB. And my restart condition, restart policy is if something goes wrong, restart it. I am also mapping a port 80 on the machines that you are running this on. So it's not one machine, but a multiple machines ingress router network. On that network called WebNet that I'm creating, this net that I'm creating, map that net port 80 to all these containers, 5 of them running in using that image. That's what I am going to do right now. So what I'm going to do is, first of all, out of these 2 machines, I have this my VM1. I'll use just one of them to begin with, and I will connect to that one machine directly. And I'll say, first of all, get to the right folder. So my folder is oh, you don't type like this apparently. You type like that. Okay, so in Windows you type like this, and then you go to the folder I'm working on, app on cluster, that folder. And in that folder, I am looking at these files. So that is the file I want to make it go to the machine number 1, VM1 here. This machine, this file that you see in the Atom editor needs to go to VM number 1. I need to copy it over. So I can do that copy very simply, Docker machine, SCP, secure copy this file, and send it to my VM1 :tilde. Send it to the home location. :tilde means it goes to the home location. So send that file, please. So it should send. And it did. It copied over that compose file, which is what you're looking at here in the atom editor. That was sent over to the machine number 1. Nice. Now let us connect directly to the machine. That's one way to operate. Or you can connect and operate on that machine without actually connecting. There are 2 ways. So the 2 ways are Docker machine SSH my VM1. It just lets you in and you are there. Docker machine will handle security and access key and everything, and then you are now in that VM. This is running Linux, and your Docker compose file is already copied over in that location. That's one way to operate. If you don't want to SSH, you can still pass on arguments such as Docker machine. And then let me just cheat sheet. What's the way to connect? Oh, not here. The cheat is probably somewhere else. You can actually pass an argument to the Docker machine command itself. That's, I think, the way to operate, but I want to make sure that I'm doing it right. So where is that? Yes, it is right. So I have to say Docker machine SSH VM, my VM1, followed by any command I want to run inside, say for example, ls-l. I'll pass that argument. It will connect, run the command, come back with the result. So it is connecting, running the command ls-l on the machine, just like I did before, and showing me the result as if I'm directly connected, but I am not. I'm still on Windows. I'm just passing an argument to Docker machine SSH my VM1. And you can see these things happen in any context, whether you're connected to a cloud or you're connected to a VM in your Windows box or a Macintosh or whatever you have. And it will just transparently connect to the box and run the command on that box and give you the result. That's 2 ways to connect. Now, having done this step, what I want to be able to do now is take that one box that I have, which is this one, virtual VM1. I want to make it run my stack. The stack that I have is this Docker Compose stack. I want to make it run that thing. So if I just say Docker stack deploy my stack, I am, by the way, directly on that machine right now. I am in Unix, not Windows. And I want to run that Docker Compose YAML, and I'll say app, give it a name. I'm going to call it app, the app.py app. And this will fail because it doesn't really understand what stack deploy is unless you configure this thing as a Docker swarm. It failed. It tells me that this node is not a swarm manager. So better use Docker swarm init or Docker swarm join to connect this node to a swarm and then try again. That's what just happened. So I need to initialize Docker swarm on the box number 1 to begin with. That's what I'm intending to do. So I will take that command, this specific command, copy it. And I don't know how to copy paste works. So actually it should work. It should be, this is Unix, so I should be able to copy this. No, it did not allow me. Whatever, I'll just type Docker swarm init. So I'm initializing a new swarm containing a bunch of machines, right now only 2, and initializing the first one right now to mark it as a beginning point. And I want you to be the manager of the swarm. So here we go. So it says, okay, I am the manager now, and swarm is initialized, and I am a manager. If you want to add a worker, you can do that. How do you do that? Go to the worker and run this. It just gives you a ready-made command with a token. The secure token is generated dynamically, and that is how you can have other boxes participate in a swarm. So I currently don't have the other box joined in as a worker. You can add a worker to this swarm, and I will add that worker to this swarm later, not right now. Not right now. Right now, just dealing with one box. So we are back into our one box. We'll leave that command alone as is. We're not messing with it. I want to copy that later on, and I will run it on the box number 2 and have it join as a worker to the swarm. I will do that later. But there is another way to get to that complex command later, which is, I think I have written down somewhere here. So if you, this is the one to get. So you're going to get that same command. You can say, you know what? Tell me again. How do you add a worker? You can ask a Docker swarm. Swarm, give me the join token to add a worker, please. So it gives you that command. To add a worker to this swarm, run this command. That's how you obtain that complex command to have other machines join in the swarm. And similarly, you want to add a manager to the swarm. You can say that, give me a way to add a manager, another manager. You are a manager. I want to add one more manager. So you add this command to generate a different token. This gives you managerial permissions. This token, as you can notice, is different from the other token. This token ends in ZMT9. This one is a different token. So that token is a manager token. This token is a worker token. So 2 different tokens to add to the swarm. You can add more managers or add more workers, depending on what your need is. We will add a worker, but later, not right now. Right now, we just have one box. In that box, what I want to be able to do is ask it to take my stack. So I'll say, you know what, Docker stack, take my Docker compose YAML and run it, please. So you can see that I will say Docker stack deploy. And by the way, hold on. Let me see if I have the file in the right location. I think I do. I have the Docker compose file. So Docker stack deploy, and then pass the argument for the compose stack and give it a name, a friendly name, such as app name. And off it goes. So it says, I'm going to create a network called app name webnet, which is what we have chosen in our Docker compose file, if you remember, right here. It is the network that I chose in line 16 and also 18 that is created right there. And then a service was created by the name web in line number 1. What does that do? What it did for us. Let us see what it did. Docker stack list. You got one stack called app name running one service. So now I want to inspect the detail around that particular stack, and I'll say Docker stack ps app name. Show me what you got. So it will tell me what is running in that particular. Is it stuck? Yeah, it was stuck. And so it is going to show me that it is running 5 different web containers, running the Cloud Genius friendly name tag, friendly name :tag image, in all of them in VM1. They're all running. And if I now visit the virtual machine 1 IP address, I can get that IP address in here maybe, and I'll say, hey, give me the Docker machine ls IP addresses of the machine number 1. Can you please give me? So it should give me, what just happened? It did not give me because I am not an admin in this window. Okay. So I will open a admin window. And here I should say Docker machine ls, and please give me IP address. Don't tell me you don't have an IP address for me. There we go. So we have 2 IP addresses, one for VM1, which is what we are primarily interested right now, and not the VM2 quite yet. So here, this is the IP address 10.0.1.84. That's what I want. So I'll grab it, go to my machine, and open it up. And I should see my app. And I do see, I should see my app. Come on. I don't see it yet. Refresh, refresh. Hello. Where is my app? It is running. I'm going to access it. So I'll open a different browser. And okay, 10 go. There we go. Now I see it. I see the app. It says hello world. It has a host name. Let's go watch it carefully. Oops. What just happened? Hold on. Something went wrong. Okay. I think I'm back and I would like to zoom it. And make it bigger if I can. There we go. So here you see that this host name is actually coming from one of these containers. So let's go see them. Let's go see the container names. So which one is it? There are 5, these web 1, 2, 3, 4, and 5 different hosts that we have. These are containers. They are sending you this hello world app. If you now try to refresh this again and again and again, you will see that the host name changes. This host name will rotate 5 different times in a round robin fashion. And that is because these 5 different containers are running behind a load balanced webnet network. This webnet network is load balancing already among 5 different containers that you're looking at here, 1, 2, 3, 4, 5. And that is all of these things running on one box again, which is the first step to getting it to run. Now, having done this piece, what I want to do is break all of this and add the machine number 2 in my cluster. So I will first of all break these guys. I'll say docker stack rm, and please go away. So it goes away. I will now check my Docker machine images. These things I need to go and erase them. So I will erase that also, which basically means cleaning up. So I'm cleaning up right now.
Hey, Nilesh, is this does it have to be odd numbers of machines like it does in normal clusters, or can you do?
Sorry, say again.
Does it have to be an odd number, right? Because
No. Let's not. Yeah, it doesn't have to be odd. So let's go see vi docker compose. And in my example, I have deployed 5 replicas of the same, right? I will now make it 50 and escape and save. Now I just made that number 50. It is an even number and also a very large number, relatively speaking. And so I think 50 may be large for this tiny little VM that I have, but I don't know, I'll take chances. Now, having done this, I will say docker stack deploy my stack and give it a name called app name. Off you go. So it is creating 50 containers right now, and it did. And so now I will say docker stack ps app name, and it should show me 50 different entries right there. And so I have them. Now I should open up my web browser again and try loading them up. 1, 2. And I get unique host names, 50 different ones, because these 50 different containers are operating in a round robin fashion behind the load balanced ingress router network. Sorry, ingress router created by Docker Swarm for us. And that is what you're looking at, which is a simple example. So we'll further complicate it. I'll like to erase this whole thing. 50 different containers, 50 replicas of the same container, by the way. So exact same app running from different hosts, 50 of them. I will now erase. So Docker stack rm app name. So the stack goes away. And since I want to now add another cluster, I will basically remove completely clean up Docker rmf, and then make a complete cleanup step. Then on my machine number 2, I will say, hey, you join the machine number 1 as a worker. That's what I will be doing in the second window on the bottom right corner. This window, I will be, oh, did I click again or something? I should not use Windows, man. I'm not really comfortable with that Windows command. It gets.
Yeah, it's not as responsive, obviously.
I know. And so this, I think it is killing 50 containers. It is taking time. That's the reason why. There are 50 of them to kill right now. So yeah, it is there. We go. So it killed. It finally killed all of them. Yeah, all of them dead. So now in our VM number 1, I will come out of it. And I'll say Docker machine ls. What do you got? 2 machines there. And then I will connect to the first one, get the token, and then connect to the second one and play the token, right? So here, Docker machine, SSH, my VM1, and you please give me the token. How do you join a worker to your setup? So here I am asking Docker swarm join token for a worker, please. And I will now connect to the Docker machine and then SSH my VM number 2. And in that second machine, I will say, hey, you go join the other guy as a worker. So the command is this thing. And again, goddamn copy and paste is a problem, but let's figure it out. Okay, right click. I don't know what happened, but something must have happened. So I'll go to Notepad, and then I don't know why I use Windows, but yeah, it is fun. Sometimes for a change, fun for me, I guess. Struggle for you guys to watch me struggle with my command line, but ouch. So I have taken the whole thing in one line, which is one way to operate, and I have this thing join the other machine as a worker. So this command is the one that is suggesting that I should type, which I will. The other way to run the same command will be on a Windows box. Say Docker machine SSH my virtual machine number 2, and then in quotes the whole thing. And that will, that you will be able to run this command in a Windows box, and this command if you're already connected to machine number 2. They're basically the same thing. I want to run this command since I'm already connected to machine number 2. I'll grab this and then go to my machine number 2 here and say, you please run this. And so I need to press enter after that. And so it is saying this node joined a swarm as a worker. Good. Now on the first machine, I'll say Docker info. It should actually show us a lot of info about how many things are in the swarm and all that. So it says there's one manager, there are 2 nodes, and it's a cluster, and all the detail you can actually go and see. It's fairly comprehensive. It doesn't have any running containers. There is one image, and it is a swarm. You can see that swarm is active. You can see that there is one manager, 2 nodes, and things like that. So you can read those details are actually useful. And that's what we have now is a 2 container swarm. Good. Now what? Now that we have a 2 container swarm, I can run my stack again. So I have my stack that looks like this. And currently As you can see, it has 50 different replicas, which is nice. But let me just make it smaller and maybe make it 5 and save. Now I want to run my stack. I'll ask my master, my manager, hey manager, why don't you run my stack for me? Docker stack deploy my stack, please. This one, and call it app name. So it'll take my stack and deploy it. But this time, the idea would be to deploy it on all the available machines. So if you now see Docker stack and say PS, it will show you that it is distributed the workload among all the boxes. 2 of them. My VM number 2, 1, 1, 2, 2. So it distributed among 2 boxes. And you can notice that, you know, in your machine here, this hello world will continue to function just like that before. And you keep getting different host names irrespective of how many machines you have. And that is what you're looking at. And this host name keeps changing as you go and hit the same IP address again and again. Now, one thing which is very, very beautiful in Docker Swarm is the idea of this ingress router, which is what I want to show you is right here. Docker machine ls. So you have 2 boxes. I want to now grab the second IP address of the second box and see what it gives us if you visit that IP address. So the other IP address is 85. This one is 84. So I'll open this 85 IP address in the other window here and say 85. And what do you got for me? And it has the same exact thing, because it doesn't really matter to us as to which IP address we connect to, whether we connect to this IP or this IP or any other IP address of the machines that you might have in your swarm. It doesn't really matter, because what Docker Swarm is able to do is orchestrate your traffic according to wherever the containers may be running and load balance across them. So back in our first window on top, if I say edit my Docker composition again and maybe make it a replica of 6 units, right? So I have my Docker stack PS showing me 5, 1, 2, 3, 4, and 5. And these are in number 2 has 3 items. Machine number 2, 2, and 2, 3 items, 3 containers. Machine 1 has 1 and 2 containers. You will notice that if I now deploy my stack one more time, it will create 1 extra container. And you can see that right here. And it will logically place it in the right spot, which is equally balanced load. VM1, VM1, VM1 3 times. VM2 is also 3 times. It balanced the load across. You can also see that particular website, the application, rendered to you by the host name, which keeps on changing across 6 different values served by 6 different containers on 2 different boxes. And you can see that, and as long as you visit any of those 2 IP addresses, it doesn't matter. And that's what you're looking at this example. Now, you will notice that it cannot count the number of visits. And so it cannot connect to Redis because our Redis image is not included in our design yet. In our Docker Compose YAML, there is no reference to Redis quite yet. Right? That is something that I want to update and make sure that I get it. So I will include that reference in our example, which I think I have to go to this location. And where is that? Page 5. I think that's where it should be. So there is adding a new service. That's what I want to do. I'm just quickly checking my notes from this website as to how that should evolve. And so I think we have an interesting example I'm just looking at that I think I should use and show to you because this is new. Okay. So what this example is actually a very interesting one. It will show you visually what is going on. And so that is what I want to do is if you look at this scenario, they have added on a visualizer service, this service. So I will take that visualizer, copy it, and bring it over to my Docker file, a Docker Compose YAML file. So I will go back to my this detail here in Docker Compose YAML, and I'll say, you know what, just add me another service, please, like that, and save. So when I save it, now I have another service added. One was this service called the web service. And now I have line number 21 through 31 is another service. And that service is the visualizer service. It is a very nice looking application, by the way. And that is why I want to add it into my Docker Compose YAML file and save it, and then copy the whole thing and send it over to my machine, VM1. So I have saved my Docker Compose YAML. I will come out of this machine, but before I come out, I want to remove my Docker Compose YAML file from the machine and then come out and say Docker machine SCP, copy my Docker Compose YAML to the my VM number 1 in the home location. So send my new file. My new file is a slightly longer file with 2 services. So I included the visualizer service, and I send that new compose, Docker Compose YAML, to my VM number 1. I can now connect to this machine and then say, why don't you run my updated stack? So I'll say, you know what, take my stack and run it. So it will do exactly what I just said, is add on a new service called visualizer, which is what we have defined in line number 21 through 31. This visualizer is a new service added on to the web service that we have already. And what does that do for us? It does show us a visualizer. Or where does it show? It will show it on port number 8080. That's where it should show us. And how do we access it? You have to go and look at the deployment placement constraints. So you can see that the deployment constraint is node has to be manager. That's where we are deploying that particular service. So this visualizer service is only one replica, not 5. So it's not 5, it's just 1. And let's see what we have. So I'm going to see inspect Docker stack yes app name. Show me what I got. So it tells me that this visualizer app is there an error here? No error. So this visualizer app is running using this image called Docker samples visualizer :stable in the machine number 1, which is the constraint we have put. The deployment constraint is you run the visualizer in the manager node. That's the constraint. So it will by definition go not to VM2 but to VM1. That is the definition constraint. We have placement constraint set. You say you go to the VM number 1, or rather you go to a manager node, wherever the manager is, any of the managers you have. It'll go there. And it uses this image, which is constructed by Mano Marks. I think that's the guy who created that image. Mano Marks. Visualizer is the image I think they have used. Docker has adopted that image from Mano and created their own Docker sample visualizer by this guy. So he first created this visualizer, which Docker seems to have taken. And so now what Docker has done is created the Docker samples repository in which they are giving you a visualizer. And that is this visualizer. Now you can see the code for it. It is basically a Node.js API and a D3 visualizer using JavaScript. That's the visual display of containers you will see as soon as you visit port number 8080 on the swarm. On the swarm meaning either here or here, doesn't matter which. So I'll go to that machine and I'll say, give me your IP address, open a new tab and say port number 8080, please. And what do we see? We see a visual representation of our swarm. And let's go see that. And so here, I'm going to shrink it a little bit. Here I see something interesting. I see that I have two VMs, VM1 and VM2. One of them is a manager, the other one is a worker. And what do I got? I got a visualizer running here. And then I have 1, 2, 3, 4, and 5 web services. One web service running in 5 different containers structured like this. 2 on the manager, 3 on the worker. And you can see interesting behavior as soon as I will play with it. You will see now something very fancy. What I will do is I'll say vi docker compose, and I will edit my composition to include some more replicas. I'll say, you know what, give me some 6 replicas, please. So replace this by 6. Oh, ouch, ouch, ouch. Windows again. Okay. Come on, Windows. Let me play nice. I should stop using Windows. I should go back to Macintosh starting 19th of June. Replace 6. And so, by the way, this Windows also brings along this Control M character, which is ugliness. I don't know why they have it. I know why they have it. I just don't like it. That's what I'm saying. This Control M is a new line carriage return combination, which is unnecessary. It's redundant, but that's how Windows writes files. So I'm going to make my replicas 6 in count and save my file. And then I will say Docker, take my stack and run it, please. So Docker stack, deploy my stack from this file and call it app name. And when I do that, watch the visualizer. It is doing right now. And I am going to see the visualizer automatically updated to show another web container right at the bottom. And you can see that it disabled pop-up. I should enable pop-up and say allow pop-up, please, because the pop-up actually brings interesting info. So if I can click on a container itself, it gives you the YAML, the JSON for that particular container directly in a pop-up window. You can see the whole JSON for that if you click on any container in the visualizer. That's the nice feature included by Mano in that visualizer. And so these 6 web containers running one web service is what you now have in our setup. You can go crazy, and crazy as in go crazy as in like this. I can say that, you know what, give me some 60 containers, please, and save it and say Docker deploy my stack, and it will do that comfortably, no problem. You can see that it's going all red right now, and this red is because it is in a state of change, and that red will eventually turn into all green web containers as soon as the thing settles down. And one of these 60, apart from these 60 web containers, there will be a visualizer container also, which is what I'm expecting to see, this visualizer container, as well as I think I must have, maybe I refresh. It must have overloaded the visualizer or something, because 60 is probably too much, but maybe not. Maybe it is just starting up. So all these red items will soon start into, it says it is starting. This is running, so it is green. This is saying starting, so it is still doing its thing, but it will do all green, and we will have 60 different containers running our web service, showing you unique host names like that. And you can access them on any of these 2 IP addresses like this. So that's your addition of a visualizer. Let's add another service to it. You can keep adding service segments like this one. We just added visualizer service to help us see the thing. We'll add one more service to include another example. To see that what we want to be able to do is, I think what I want to do is add a Redis service. So here is a Redis service. I'll take that and add it to my composition like this. And I'll say, you know what, in addition to this web service and the visualizer service, I would like you to include one more service. That is the Redis service. And this service runs the Redis image, and it exposes port number 6379 and maps it to the internal ingress router network. It stores the data in this location /data. And its deployment constraint, it will be only one box, by the way, only one box, and it will be running on the manager. This, again, I said the word box. No, there is no box. This Redis image will run as a Redis container on the manager box. That's how I should say it. And you use the same network called WebNet, which is what we have set. And our replicas are 5, which is what we understand. So I'm going to save it, close it, and then come back here and clean up. So I'll clean up right now, Docker stack rm, and another cleanup, Docker rm -f. This is completely erasing all the instances of previous containers right now. There we go. So it should take a few seconds to clean up all the 60 or so containers we have, and then gives us room for us to play that next step, which is inclusion of the Redis image. So now let's go see. Yes, clean. I'll exit and go back in and delete that file in there, that Docker compose YAML file. I want to kill that file completely. So I have that file in here. I will say rm go away and then come out. And then I will say, you know what, take my new version of the Docker compose YAML file and send it to the Docker machine number VM number 1. So it is sending that. It's sent. Now I will connect to the machine directly. And now play the same example the same way we have been doing before. Same thing, except we are going to see the Docker file clearly, whether it's completely available locally. And it looks like it is. It has the Redis image, it has the visualizer, and it also has the friendly name tag, the application we created. So now that we have our composition clear, we'll say Docker stack. Where is my mouse? Okay, Docker stack deploy, and take my stack and run it. So it runs it. This time it will pull the Redis image and create one container in the VM1 box. And that is that service, the Redis service. We have a visualizer service also running on the main VM1 box. And that is what we are looking at here in the visualizer. We will go and see that it has our visualizer running. It has, oops, did not want to double click. I want to refresh this page. And I want to see my Redis service, which is not visible yet, but my visualizer is running and my 5 web services are running, but whatever happened to my Redis? Come on, tell me, what just happened? So that's what I will go and inspect. What just happened to my Redis service? Is it really running right now? the Docker stack ps app name is my Redis service running. And now it is getting shut down for mount config, invalid mount config. So I think that application example that I copied from here has this mount configuration incorrect. It doesn't match my setup. I need to remove that line. That is why I copied and pasted from that website, which is not matching my design. So it is causing this error, which is saying invalid mount configuration, which is basically the mount point or the volume mapping was incorrect. It did not fit my case. So I will remove that reference and also remove that reference from my Docker Compose here. And I will say these lines should go away, which is what I want to do. And that should fix the Redis problem. So I remove those two lines and I'll say Docker stack deploy once again. And it should deploy my Redis service correctly this time. And that is what I'm waiting to check. It seems to have started, updated the Redis service, but let us see Docker stack ps app name and see what we got. Invalid mount. Oh, is this old or what? Let me just check what we see in the, there we have Redis. We have Redis there. It is running. But why are these, I should have cleaned up and did it again. So let me clean up and do it again. I think that's the best way. So Docker stack rm. So clean up and Docker rm -f or Docker ps aq. That cleans up all the containers, and then we will deploy our stack in a fresh, clean setup. That should start 3 services: web service, visualizer service, Redis service, and 1 network, and should show us healthy state. Docker stack ps app name should show me healthy. And yes, I see no problem now, which should take me here and show me my visualizer running the Redis service right there, running 5 copies of the web service in 2 boxes, and the visualizer itself is also running. And so with that, we'll go back to our IP addresses of these 2 boxes and see what they got for us. So we will go and say, hey machine, what do we got? So just show me what you got. It says number of visits 1. Somebody's keeping track of it now, right? Earlier it was like cannot connect to Redis, counter was disabled, but now somebody seems to be keeping track. So refresh, it says 2 and 3 and 4 and 5 and goes on and on like that. And so back here, and 8 and 9 and 10. And you have different host names serving different visits, because that's what load balancer is doing in the ingress router that Docker Swarm has given us. And we are visualizing these things in our visualizer, which is, by the way, a fantastic application. I really like this visualizer, and we are able to include that in the demo to help us understand these details as we went along. So that is what we successfully did in this setup. So what I'm going to do now is send this entire app on cluster atom folder to you in a Git repository. This is a fresh new exercise we just did. I never did this before, and also never did it on Windows, so which is another crazy thing. So close it. I am going to push this in a Git repository and send it over to you in Slack chat. And I would suggest that you do it either in Windows or in, hold on, where did I write that? I think I wrote that in these 3 places. So you can do that exercise either directly in Windows or directly in a VirtualBox on a Mac, or run it in the context of a cloud. You can choose your cloud and you can, play with. This is how I used to do the exercise before, like this. But since I have Windows, I wanted to play with it. So I just modified it to include Windows with Docker installed. And that's what I just did. The first time in my life, never played with it, but it worked out okay. But that is a lab exercise. This is not how you run it in production on a Windows 10 box. This is the production way of doing things. Right? You create a cloud connection. You have to provide your digital access token and then create these machines as you like, any number of them, and put them in a cluster by running something like initialization. And it will give you a command that looks like this, that will allow your swarm token for other workers to be able to join. And then you have a swarm. Once you have a swarm, everything is beautiful, because you then have these methods of deploying a stack and play with it, multi-machine, multi-container. And remember that you are not tied to any cloud at any point in time, because you can take the same exact infrastructure and run it in any cloud whatsoever. Any cloud whatsoever, as long as you have a operating system that is Linux. And it can, once it has Linux, it can run Docker. And once you have Docker, you can have multiple machines connect together to run Docker Swarm. And then you automatically get this ingress router and load balancing and all the scenarios that we played with in multiple boxes, multiple containers, and you get to decide how your services will work according to what you define in this Docker Compose file, which is, we have 3 services: the web service. The visualizer service is something that you don't want to run it in production. You don't want, you want to cut this actually. You don't want to run it live in production. You want to go like this, just 2 services, web and Redis. For testing, you keep it. Test it out. And then when you're done testing, remove the visualizer. You don't want to waste your CPU resources on that thing. And build around your application. So whatever you want to run. So here is a simple example application. You need to create your application's image. This was a trivial Python application that used this Docker file to construct an image that I call Cloud Genius friendly name : tag. That's the name I chose. But if you have a more complex application, I have a Ruby example for you in our website here. You should be able to construct a fairly complex image for a fairly complex application in this example coming up. Where is that? Yeah, here, module 10. This is a just creating a Docker file image for basically Dockerizing or containerizing a custom application, Rails app. So that's how you go about doing it if you are interested. I'm not sure if you are, but if you are, I will play this exercise for you. It is written down already. You can just check it out. And that at the end, you will have an image. And once you have that image ready, you can then create a compose file. Pretty much like this, Docker Compose configuration. You have dependency on Postgres image, dependency on Redis image, and you create your own build. You build your own image like this, and I'm calling it the Cloud Genius image. You have more dependent side containers called Sidekick. And so this is a separate worker container, not worker machine, worker container that will help your application do side business, like other things you may want to do. So this is a general purpose frame of reference of thinking a slightly complex application that you put together in form of containers, and you build that container just like this. The build step will do it for you, and you bring this stack up, Docker Compose app, and it will start those services and run your app, and you can then scale it. The scaling was simple. If you see and you remember the scaling was line number 8. How many replicas you want? You can grow and shrink simply by changing and redeploying the stack, and it grows. That's growing containers. If you want to grow the underlying number of machines you have to go back to the previous exercise we did here. For example, we did what? What was it called? AWS auto scaling. Yeah, that exercise we did a while ago, right? You have to put these machines that you have in an auto scaling group. And what that will do is automatically grow and shrink the number of machines you have, on top of which you create a cluster. That cluster itself will grow and shrink depending on number of machines that are needed for auto scaling. And then in that variable size cluster, you deploy your containers. And the container count is controlled by this number. Replicas, how many you want, and how do you want to spread, and how do you want to load balance, and how do you want to resource constraint, how many CPU, how much memory. For certain images like Redis, it needs a lot of memory. So you have to not put a constraint on memory and actually decide to run this Redis on a dedicated machine, something like a big box, for example. And so you need to understand these parameters as to how your application performs, and then put that in the context of a composition like this, and play in a auto scaling, auto growing, auto shrinking machine configuration like this, and run your swarm on top. That's the open source way of doing things. There is always a commercial way of doing things also. So you can go and find that out if you like. The commercial way of doing these things are called, what do they call it? It's called ECS, EC2 Container Service. So they give you a service, this one, that will do everything for you. And I don't like it because I don't want to use it. I don't want to get stuck with this. So I want to remain independent. This, by the way, is a good service. Nothing wrong with it. Totally nothing wrong. The only thing wrong with it is that if you are using it this way, then you cannot run it the same setup in another cloud. You have to modify your setup. You have to go change it to run it on Google Cloud, or change it to run on Amazon Cloud, or sorry, Azure Cloud or some other cloud. That is bad. That piece is what I don't like. Apart from that, beautiful service. Run containerized application in production, get started pricing and all that. Yeah, go ahead, do it. It also is Docker, by the way, nothing different. This is also Docker, but it is the Amazon way of running Docker. Same thing here in Google Cloud, cloud.google.com. This is the Google's way of running containers, Docker. Go to console, and here is the Microsoft way of running containers, Azure Container Service, ACS. This container service runs both Windows and Linux containers, and you can try it out. It is available now. They have purchased this company that we did an exercise on. If you remember DACE, they bought that company to enhance. We did a DACE exercise, if you remember. They have purchased that company. I think I talked about it already to you. So Microsoft to acquire DACE to help companies innovate with containers. So the ACS is going to be expanded using DACE software, which is open source. It will remain open source. And that is the Microsoft way of running containers, which is nice. And so the my way of running containers, if I can call it my way, is this: is run it in a fashion that it runs everywhere. And then you have the ability to pick your cloud. And that is what I think is most important in case of not getting stuck with a vendor, and to remain fungible. To keep clouds fungible is the idea that I describe here in this blog post somewhere here. Long ago I wrote about it, 2012 or something. But that's what fungible clouds are to me, where I really don't want to get stuck with a company. So read that if you're interested, and I will see you again on the next time, at which time I will do another way of deploying containers, the way that is known as the Kubernetes way. And it is slightly different, interesting, and it runs everywhere as in wherever you can run Linux, you can run Kubernetes. They're also expanding their support to make Windows run, which is nice. And we'll play this Kubernetes. It's fairly comprehensive and complex to understand to begin with if you're not used it before. But we will run live examples, live exercises, and understand pieces of it as we operate on it. So today is 7th. We'll meet again on 9th at 4 o'clock Pacific time, 7 o'clock Eastern time. And at that time, I will start the same number, same conference session again. And right now I am going to stop recording. Thank you.